Good afternoon and welcome to this demonstration. Today I'll be presenting on augmented reality baggage measurement. This is a collaborative project between the University of the West Indies and Caribbean Airlines Limited and serves as my ECNG 3020 final year project. The project supervisor is Dr. Akash Puran Singh, and the industry contacts from Caribbean Airlines are Avikash Harira and Anil Ali. This project sought to design and develop an augmented reality module for the Android operating environment, and this module will allow passengers to size or to measure their carry-on items at home. The module will also provide some sort of feedback to passengers and let passengers know whether or not the bag or the item that they're scanning actually fits as a carry-on item. The development of this library or this module was done in phases and iteratively. This means that according to an original set of specific requirements, an initial prototype was built and additional features were layered on until all the specific requirements were met. Firstly, this application was required to provide an augmented reality interface for passengers. It was also required to detect ground planes and allow the placement of virtual three-dimensional objects. So I'll go into the first phase. Now, if we open this application, we can see the augmented reality interface and white indicators showing where the application has detected the ground plane. At this stage, I can also tap to place a three-dimensional virtual object. However, this virtual object is not a custom one as it is shipped with one of the APIs being used, namely ARCO. The second phase of this application was built to be compatible with React Native. Caribbean Airlines' current mobile application uses React Native, and thus the module was meant to be installed into their current application. However, React Native doesn't inherently support augmented reality, so the React Native bridge was needed. This is a programming construct which allows communication between the JavaScript or the React Native side and native or Java Android classes. So if we open phase 2, we're greeted with a different interface, and this is the React Native side. If I click Launch AR, an asynchronous function then launches an Android intent, which starts the native Android activity. The interface has been improved slightly with a delete button on the top right for the removal of placed 3D objects, and at the bottom there's also a radio group to choose the type of object being placed. If I tap here, we can see custom objects being used in the shape of a bag and in Caribbean Airlines' signature Pantone purple. Additionally, if I click on the radio group, I can choose the type of objects being placed. At this point, we can also manipulate the object. However, we can note that we can't actually scale the object, and that's very important. Since for measuring a given item, we don't want our reference item to be scaled arbitrarily. This does mean, however, that the further the object is from my field of view, the smaller it will appear. And this again is important to ensure that, for example, if a passenger tries to measure an object at an appreciable distance, the parallax error is accounted for. The third part of this application design, or the third iteration, is user feedback. So this is where the application can generate some sort of response to a user scanning a given real-world object. So I'll demonstrate that now. If I open the final iteration, we can click Launch AR, which takes us into an interface that hasn't changed much since the last iteration, except for a text prompt at the top of the screen. So now I can place the three-dimensional virtual object on the detected plane, and I can walk around to scan this bag. Now note that the three-dimensional object does not need to completely encompass the bag, and we can see there that the correct response has been generated. Try this with another type of object. such as this backpack. So I always use this to simulate, for example, a duffel type object, and also because the backpack has trouble actually standing on its own. So I'll select the duffel item, click duffel, and walk around. And we can see the feedback being generated by the application, and it says it can't qualify as a carry-on, which is correct, since the dimensions of this backpack exceed ever so slightly the dimensions as required by the app. Those are fairly typical objects. We're now going to scan a rather atypical object for a carry-on item. So if I click launch here again, scan the flow, and this time we're going to use this personal item object type. Tap and overlay. We can now scan the object, and we can see real-time feedback being provided to the user where the feature points are being highlighted in the app interface. Now the feedback provided is correct, as the item does indeed fit in the space required for carry-on. The final item being used for demonstration purposes is a closed basket, since it represents one of the few edge cases existing for the application, and this is for very thin-walled or hollow objects. So if I put this here, again launch ER, and I use the typical carry-on item, I can put the item over the basket, and the response here may or may not be accurate. Now, it says it qualifies as a carry-on, however this is not correct, since the width of this basket, the diameter of the basket, exceeds the size as specified by the carry-on. Now, in the last few seconds of that demonstration, the correct response was generated. However, that was the point of the demonstration. This represents an edge case where not enough accurate points are mapped to this object owing to its edge nature. Therefore, this is one of the challenges existing with the application. A possible improvement is the inclusion of object recognition. So, for example, we have an application implemented here which can register different types of objects, and we can possibly use this to classify and inform passengers before they even try to measure the size of the object, whether or not it is a viable carry-on item.